Good evening. Second question. Discuss the continuity of the following functions at the point or points or on the interval indicated against them. Let us discuss third one. F of x is cos 4x minus cos 9x upon 1 minus cos x, x not equal to 0. F of 0 68 upon 15 at x equal to 0 on closed interval minus pi by 2 to pi by 2. Now cos 4x, cos 9x, 1, cos x are all continuous on capital R. So this is continuous on this closed interval except at the point where denominator vanishes. That is 1 minus cos x equal to 0. That is cos x equal to 1. Now in this interval, cosine ratio is equal to 1 for x equal to 0. So let us discuss continuity at x equal to 0. F of 0 is given to be 68. Let us evaluate the limit. Cos a minus cos b minus 2 sine of a plus b by 2 into sine of a minus b by 2. What is 1 minus cos x? 2 sine square x by 2. Now same logic. Angle must be fully repeated and so on. You have to rearrange the terms. You have to adjust constant terms. So everything is done here. Constant part comes out to be 65. So what is the value of limit? 65 not equal to f of 0. So function is discontinuous at x equal to 0. But while writing final answer, we have to say f is continuous on closed interval minus pi by 2 to pi by 2 except at x equal to 0 where it is discontinuous. Now third question. Discuss the continuity of the following functions at the points this is second. Let me read the third one. Okay, third one. Identify discontinuities, if any, for the following functions as either a jump or a removable discontinuity on their respective domains. First one, f of x is x square plus x minus 3 for x belonging to semi-open interval minus 5 minus 2 equal to x square minus 5 for x belonging to semi-open interval minus 2 5. Here you will notice that minus 2 is actually not part of the part of any of the interval. Now given function is a polynomial function. Polynomial function is continuous on R. Continuous means defined. So it is continuous on these intervals also. So let us discuss continuity at x equal to minus 2. Limit, let me explain. Limit extends to minus to minus, means to the left of minus 2. So which function we have to consider? X square plus x minus 3. Now limiting value is minus 2 only, not because of this minus, because of this minus. So take limit, left hand limit comes out to be minus 2 square is 4. 4 minus 2 minus 3, that is minus 1. Right hand limit, you have to consider this function. Again same, right hand limit comes out to be minus 5. This means limit of the function exists. But note that this should be f of minus 2. F of minus 2 is not defined. So function is discontinuous at x equal to minus 2. But as limit exists, this discontinuity is removable. How to remove this? We define function at x equal to minus 2 as what? Its value is same as value of the limit. So ultimately, f of x equal to x square plus x minus 3, x belonging to semi-open interval minus 5 minus 2 equal to x square minus 5, x belonging to semi-open or semi-closed interval minus 2 5, and f of x is minus 1 for x equal to minus 2. Fourth question. Discuss the continuity of the following functions at the point or on the interval indicated against them. If the function is discontinuous, identify the type of discontinuity and state whether the discontinuity is removable. If it has a removable discontinuity, redefine the function so that it becomes continuous. First one, f of x is x plus 3 into x square minus 6x plus 8 upon x square minus x minus 12. Denominator can be factorized as x minus 4 x plus 3. Now this is a rational function, so it is continuous except at the point where denominator vanishes, that is denominator equal to 0. It is 0 at x equal to 4 and minus 3. Now limit extends to 4. F of x equal to, what is the value of this limit? Cancel x minus 4. So take the limit. So 2 is the value of the limit. We can cancel x plus 3 also, right? So f has a removable discontinuity at x equal to 4 because limit exists. What is limit extends to minus 3 fx? Evaluate that limit. It is minus 5. Limit exists. So f has a removable discontinuity at x equal to minus 3. Hence, f is continuous at all points of its domain, which is set of real numbers, except at 4 and minus 3, where it has removable discontinuity. We redefine the function as follows so that it becomes continuous on capital R. F of x equal to what? X plus 3 into x square minus 6x plus 8 upon x square minus x minus 12 for x not equal to 4, x not equal to minus 3, and f of minus 3 minus 5. And f of 4, it is nothing but 2.
Fifth sum. Find k if following functions are continuous at the points indicated against them. First, f of x equals 5x minus 8 upon 8 minus 3x raised to 3 upon 2x minus 4 for x is not equal to 2, and f of x equals k for x equals 2 at x equals 2.
Actually, function is given to be continuous at x equal to 2. So f of 2 must be equal to value of the limit. That is k equal to value of the limit. Now, in standard limit, you will notice that x tends to 0. Here, x is tending to 2. So we have to put x equal to 2 plus h. As x tends to 2, h will tend to 0. So limit h tends to 0. 5 into in bracket 2 plus h minus 8 upon 8 minus 3 into in bracket 2 plus h raised to 3 upon 2x minus 4. That is, I'm sorry, 3 upon 2 into 2 plus h minus 4. Simplified to get this. Now, this gives limit h tends to 0, 2 plus 5h upon 2 minus 3h. And what about index? 3 upon 2h. Okay. So this is limit h tends to 0. Within radical sign, take within bracket, take 2 common from numerator and denominator, because we need 1 plus. So 5h by 2. And here if you take 2 common, 1 minus 3h by 2 raised to 3 upon 2h. So 2 gets cancelled. Limit h tends to 0. Now 1 plus 5h upon 2 raised to 3 upon 2h upon laws of indices 1 minus 3h upon 2 raised to 3 upon 2h. Now limit of quotient is limit of numerator upon limit of denominator. Now something is added to 1, same thing tends to 0. Required index is reciprocal of this. So 2 upon 5h, but this is not original, this is required. To get original, see 2 upon 5, that is why 5 by 2, so that this gets cancelled. But original index is 3 upon 2h, so into 3 by 2. If you verify a raised to m raised to n, a raised to mn, yes, you get the same only. What about denominator? Required index is reciprocal of minus 3h by 2. So minus 2 by 3h raised to again minus 3 by 2. So this constant gets cancelled into 3 by 2. Now, this is nothing but e raised to 15 by 4 upon e raised to minus 9 by 4. Laws of indices. This is e raised to 15 by 4 plus 9 by 4. That is e raised to 6, which is f of 2. As function is given to be continuous, but f of 2 is k. I should have written equal to k. So value of k is e raised to 6. Actually, we should mention the reason also. Please write that. As h tends to 0, these two tend to 0, and limit y tends to 0, 1 plus y raised to 1 upon y equal to e. I repeat this. As h tends to 0, phi h upon 2 and minus 3h upon 2 both tend to 0, and limit y tends to 0, 1 plus y raised to 1 upon y is e. Sum number 6, find a and b if following functions are continuous at the points or on the interval indicated against them. First one, f of x equal to 4 tan x plus 5 sin x upon a raised to x minus 1 for x less than 0 is 9 upon log 2 for x equal to 0 is 11x plus 7x cos x upon b raised to x minus 1 for x greater than 0. Now f of 0 is given to be 9 upon log 2 for x equal to 0. I'm sorry. What is given? Yeah, for x equal to 0. Now let us find left hand limit. Limit x tends to 0 minus. For that we have to select this function. Divide numerator and denominator by x. You have to mention the reason. X only tends to 0, not equal to 0. Now limit of quotient is limit of numerator upon limit of denominator and so on. All are standard limits. So this is 4 into 1 plus 5 into 1 upon log a. So 9 upon log a is nothing but left hand limit. So clearly, what is the value of a? It must be 2, but that will not write at present. We'll obtain the right hand limit also, then we'll find the values. Now right hand limit extends to 0 plus fx 11x plus 7x cos x upon b raised to x minus 1. Divide numerator and denominator by x. So 11 plus 7 cos x upon b raised to x minus 1 upon x. Limit of quotient is limit of numerator upon limit of denominator. Now evaluation of limit is not at all difficult. Limit of constant is constant. Limit of 7 cos x, cos 0 is 1. So just 7 into 1, that is 7. So 18 upon, this is standard limit, log b. So 18 upon log b is the right hand limit. Now function is continuous. It is given to be continuous at x equal to 0. So limit x tends to 0 minus fx is f of 0 is limit x tends to 0 plus fx. Equate 9 upon log a is 9 upon log 2. So log a must be log 2. So a has to be 2. Now this is 9, this is 18. So this is 1 upon log 2 is 2 upon log b. So it is log b 2 log 2. That is log of 2 square. That is log 4. So b equal to 4. Actually, we should write answer separately. A equal to 2 and b equal to 4. Right now. Actually, second sum, we have solved similar sum in MCQs. So first, you should try this before you refer to the solution. Sum number 7. Find f of a if f is continuous at x equal to a, where we'll be doing first part in that a is 1. Okay, a is 1. F of x is 1 plus cos pi x upon pi into square of 1 minus x for x not equal to 1, and a is nothing but 1. Okay. So f is given to be continuous at x equal to 1. So what is f of 1? Value of the limit. Now we put x equal to 1 plus h. As x tends to 1, h will tend to 0. So limit h tends to 0, 1 plus cos of pi into 1 plus h upon pi into 1 minus h. So 1 minus 1 minus h it will be. So limit h tends to 0, cos of pi into 1 plus h is pi plus pi h. Cos of 180 plus theta is minus cos theta. So it is 1 minus cos pi h upon pi h square. You may say, as it is 1 minus cos pi h, can we multiply by 1 plus cos pi h? Yes, that can also be done. But here I have used the result 1 minus cos theta is 2 sine square theta by 2. But why 2 square? Because it is sine square. We cannot just multiply by pi square by 4. That is square of pi by 2. So we have to multiply numerator also by the same. This 1 upon pi I have written outside the limit. So next step, this is 1 upon pi into 2 into pi by 2 square. I will write pi square by 4. And what is limit of square? Square of limit. You should not write this directly. This step is be written. So this is effectively pi by 2 into 1 square, which is nothing but pi by 2. So f of 1 is nothing but pi by 2. Please check this. Of course, reason should be mentioned. As h tends to 0, h by 2 tends to 0, and limit y tends to 0, sin y upon y is nothing but 1. Right now. Sum number 8. Solve using intermediate value theorem. First is for homework. Second, show that x cube minus 5x square plus 3x plus 6 equal to 0 has at least 2 real roots between x equal to 1 and x equal to 5. Let me tell you, see, if root is a complex roots always occur in pairs. So this will not happen that this equation has 2 real roots and 1 complex root. No. If they say that 2 real roots, third has to be real only. Anyways, you have to use trial and error method. Given interval is 1, 5. Find out f of 1, it comes out to be positive. Find out f of 2, it comes out to be 0. So actually we are asked to just show that there lies a root. But we have got f of 2 equal to 0, so 2 is the exact root. Now, we have to find other root. See, I have chosen integral values. You may be required to consider fractions also. Like f of 4 is, say, positive, f of 5 is positive, rather f of 4.5 is positive, but f of 4.3 is negative. It is possible. But here, luckily, f of 3 is negative, f of 4 is positive. So, please do not write in this fashion. Here you have to say, therefore, by intermediate value theorem, for continuous function, f of x equal to 0 has a root between 3 and 4. This means f of x equal to 0 has at least 2 roots in interval 1, 5, 2 and other between 3 and 4. It is possible actually that other root may not lie in this interval, but in all, x cube is there, so this equation has 3 roots. If 2 are real, third has to be real only. This will not happen that 2 are real and 1 is complex, because complex roots always occur in pairs. So that's it for today.